room. Okay, so the next presentation will be from, let me try to pronounce it and you can then do it the proper way. Tomáš Podermanský, from Brno University of Technology in the Czech Republic. He's a network admin, researcher, works in the Géant project and many more things. And he's going to talk to us about how the world changes in terms of security with the massive rollout of IPv6. Tomáš.
Okay, thank you for introduction. And at the beginning of my presentation, I would like to ask you, who thinks in this audience that IPv6 provides us better security comparing to IPv4? Put your hands up. Nobody. I can't believe. And who thinks the opposite, thinks that IPv4 provides us better security than IPv6? Oh, few hands up. Oh, so we will see what's going on here. Many people think that IPv6 provides us better security comparing to IPv4 because there is mandatory support for IPsec, there are technology like SEND, etc. But we can say it sounds great. It was the initial goal of IPv6, but in reality, it's not true at all. Let's imagine a situation when we have one network segment connected with switches, connected to the router. It doesn't matter whether it's Ethernet network or wireless network, and try to look what's going on the network when the computer starts to communicate over the network. Let's have some computers on the network, and in IPv4 world, it was quite easy. At the beginning, when the computer tries to send packet to some destination over the internet, we try to ask the DHCP server for address, then we resolve with two packets ARP resolution, relationships between IP address and MAC address, and then we will able to establish connection, let's say, to HTTP server. In IPv6, it's a little bit more complicated because we use more protocols for this purpose. At the first stage, as IPv6 doesn't support broadcast, so we start with multicast joining address to be able to communicate with the router. Then we follow with neighbor solicitation, and we start with stateless auto configuration, get information from router about default router and other parameters needs to communicate over the network. And we follow with DHCP server, where we get the address for the computer. And again, for this address that we get from the DHCP server, we again continue with MLD discovery, and for both address gets from stateless auto configuration and DHCP server. Then we follow with the neighbor solicitation and neighbor advertisement. It is very similar to things that we do with ARP in IPv4, and then we are finally able to send the regular traffic over the network. As we can see, this is much more complicated, so there is bigger possibility to manipulate with these packets to unwanted actions. A very simple example can use duplicate address detection that we use in IPv6. It's a brand new thing when the computer configures own IP address, ask the network whether this address is used already on the network. And attacker very easy can answer, this address is already used, choose another one. And computers try again and again, choose new address and detects whether this is available on the network or not. There is a simple tool that can show you how this attack can work and how it works in reality. We send neighbor solicitation to the network, and we get neighbor advertisement report from the attacker, and it repeats again. And the result is on the Windows machine that this machine doesn't have configured IPv6 network. All right? So we have only one link local network. We expect that IPv6 will work on this device, but not. And of course, different platform works with this dot packets in different way. For example, Windows platform tries 5 times to attempt to create new address and then gives up. And address is not configured on the interface. Linux use different approach, completely ignores that. Even this address is duplicate, Linux ignores it, and nothing happened, but it works at all. Very funny behavior is on the HP layer 3 switches. When this duplicate address is detected, the address on the interface is down forever, and you either reboot the switch, what is the problem? It's a router in many cases, or you have to unconfigure IP address and configure it again. So, but the result of this is user is not able to communicate over the network with IPv6. Okay, let's say it's not a problem, it's only IPv6. We still have working IPv4 connectivity. There is not much IPv6 traffic today, so it's not a problem. It's a problem only of IPv6, and this problem probably will be solved in the future. But there is another example of auto-configuration issue known for many years, 3 or 4 years. This issue is known. Almost all vendors were affected by this issue. It's flooding with router advertisements to the network. The result of this command is that all Windows boxes will freeze when this attack is performed. You are not able to even move with window, move with mouse, etc. Microsoft and Juniper and other producers were asked to repair this problem, but the result is that nothing has happened. Juniper replies to these people that it's a problem of ITF, and ITF first should fix the problem in the standards, and then they will fix it in their devices. If we will be success, you will see, yeah. On this video, we can see how it works in new Windows that will be released in 1 month. This is a video taken from a release that was released for enterprise customers, I think 1 month ago. It's Windows 8, final version, and we run this flood attack, and you can see in a few seconds you are not able to do with the system anything. You are not even able to move with window. Nothing is working. In many cases, users have nothing to do, then reboot this computer. If we can look at it's not visible here, right? But there is several packets that cause this problem on the network. So it's very difficult to find the source of these packets. And if we stop this flood, you can see here. Some of you maybe see here that we stop this flood, and Windows recovers in a few seconds from this problem. I have to say that in Windows 8 is much better than, for example, in Windows Vista, when in Windows Vista we had to reboot the system after this attack, so it's definitely better than before. But the result is here. So the IPv6 connectivity has affected not only IPv4 connectivity, but whole system. Of course, there are several tools that you can play with. Not only these attacks that we have shown on this presentation, but there are many other interesting attacks that we can perform on IPv6. There are 2 basic tool sets: THCP Attack Toolkit from Mark Heuss and CNetworks IPv6 Toolkit from Fernando Gont. Both packages do very similar things. But in the previous presentation, we show only activities that were destructive to IPv6 or whole network connectivity. But it can be even worse. Let's imagine that almost all devices that we have here support IPv6. I think there is no devices that doesn't support IPv6 and doesn't have enabled IPv6 enabled by default. So we can perform another attack. Let's imagine back just the same network that we have at the beginning, and the computer that wants to communicate to some site. And attackers establish raw router, IPv6 router, and sends to the network router advertisement that says to the clients that they should use the HCP server for configuring IPv6 address. Clients ask the HCP server for IP address and it replies, and in this reply, the HCP server sets own set of IP address of the recursive DNS servers. And from this time, the attacker have all control over your traffic to the DNS server, so he can manipulate with these records and change the change the answers that you want. It's an example in this video. It's a little bit longer, but it's tested in my home network because I always tempted to show to everybody this online, but it's against the law in some countries, so it's a little bit tricky to do it. But it's an example performed in my home network. We can see Windows machine with configured one IPv4 address and one address of the DNS server. We can try lookup to some famous sites, Google.com, let's say. We can see few IPv4 address and one IPv6 address. Let's say Facebook. We see several IPv6 address and few IPv4 address, and let's say test Google.com, Yahoo.com, right? It works fine. And now we switch to attacker's computer. I hope we will see something. We run several tools. Sorry for these colors. I hope we will be able to see anything at least. At the first stage, we start namemat, and this namemat is modified that for some zones like Google and Facebook use own zone file. We will see what is in this zone file right now. If we look in this zone file, there is only one address. Oh, sorry. There is only this zone file returns or records with star to address of the attacker's computer to this IPv4 address. The next software that we run on this attacker's computers is Squid, is a proxy server. DHCP server, and configuration of this DHCP server is very simple. The only thing that is in configuration of this DHCP server is list of IPv6 recursive name servers. We put there more name servers because Windows uses round robin for using IPv6 servers. So there is a bigger chance that Windows will use our name server for resolving names. We can see that all these addresses are set on the interface on the attacker's computers. And the last thing that we run on these attacker's computers is a router advertised daemon. That we can see the managed flag is enabled. Through this flag, we tell to the computers that clients should get IP address and other configuration options from the DHCP server. And now we can switch to the third screen, where we can see three parts. The first part shows us the number of requests to the DHCP server. The second part displays us the name that was used for resolving through our name server, and the third part parses outputs from Squid logs. We have to wait for a while when all devices get IP address from DHCP server. We can look at it now, and it's not happened yet. So we will wait for a while. it usually happens that Windows get address immediately, but in testing environment it not happened always. Sometimes we have to wait about 2 or 3 minutes. Now we can see that we had on the DHCP server 3 requests. It's a request from all my 3 devices that I have at home. And if we look at the list of the recursive DNS servers on the Windows machine, we can see it's the list that we just set through the our DHCP server. Now we can try to resolve Google.com again. Oh, it's our address of attackers' computers. It's exactly what we wanted to do. Let's say look at the Facebook.com. Right, just the same address. But we try to Yahoo.com. Yahoo.com returns a real address. So we can select the traffic that we are interested in through this DNS server and redirect to our computer. Now we start run browser and try to run Google. And search something. We can see on this bottom line that there are some requests on Google. And as we can see, user is not able to recognize that traffic is redirected from some other computer. As we can see, the number of requests to Google is growing up. Now we can join to Facebook. We can see this request on the proxy server. Everything works fine. User is not able to recognize anything. We can go through these pages, and user is not able to recognize anything. Until the moment when the user logs out and tries to log in back. Oh, we were waiting for this screen. Is the first phase where the user is able to recognize that something wrong has happened. But I bet that a lot of users just will do this step. Oh, I need my Facebook immediately, right? Even though it's written that this fake certificate do not accept it, I bet that a lot of users will accept it with not reading this information. And confirm. I'm sorry?
Did you try the same thing with Chrome?
No. I tried it with Explorer and Mozilla. It's a good idea. Okay. No, certificate name is not a problem because this.
They do cert pinning, right? So they would send you the certificate key hash in a header. And
oh yeah.
Bet you that Chrome would display a different dialog.
Okay. So I will. Thanks for idea. And in the meantime, we check this certificate, for example, in this browser is accepted forever. In Thunderbit is a little bit better because the name of the certificate is the certificate and the name of site is not. In some browsers, the certificate is accepted for all sites. So every site that I redirected through this way is accepted forever and user is not able to recognize anything. Okay, so somebody can say that this was issues related to IPv4. We can do similar things in IPv4 as well, so it's true. But in IPv4, we know things like first hop security, how this security works. Let's imagine that we have computers on the network, and on the access ports that the devices are connected to, we can apply some special security rules. In IPv4, it's pretty easy. All is based on DHCP database. So when the computer is connected to the network, then ask for the IP address, and we create the database of MAC address and IP address, and on the port where the user is connected to, we can perform several checks like inspect ARP packets, or we use extra level of security that we block any traffic that not belongs to specific MAC address or IP address. And it becomes more and more important, it's first security, because today we are building big networks. For example, it's typical that 3 or 4, not 3, 4 or 2 C subnets are joined together in one computer. So we have around 1,000 of devices on the one network. And there are also some Trojans that uses these problems, and we try to guard someone against that. For example, 2 months or 3 months ago, the necessary changer was a quite big story. So, how it works in IPv4? In IPv4, we have all this protection mechanism on access ports that the user is connected to, but however, it doesn't mean anything to IPv6. If we have implemented these features on IPv4, IPv6 is free. There is no protection on IPv6, and we can do all these things that we shown here over IPv6. Of course, in IPv6, we have also some possibilities how to solve this problem. The most discussed is secure network discovery, where all these network discovery packets are encrypted and signet and checked on the computers, but however, there is no implementation of this mechanism today. There is no implementation for Windows. There are some experimental implementations for Linux. Another solution is router advertisement guard. It's implemented on some Cisco devices, but there is a way how to avoid this protection in intentional attack. It was presented 1 year ago, and right now there is no solution how to solve it. Another level of protection is SAVI, is a project of ITF, Source Address Validation Improvement. It provides complex solution, including address inspection, etc., but the level of protection is not just the same as we can see in IPv4. So, as we had the table for IPv4 attacks and protection against them, there is a little bit more attacks in IPv6 and the way how we can protect against them. We said that send is not option today, but there is a problem if there is intentional router advertised. There is currently no protection against this problem. So in many cases, less desired option is either blocking IPv6 on the access ports, if we are in an environment when the risk is very high of these problems, or disabling IPv6 on devices. But we want to deploy IPv6, so it's a problem to put this policy on the network. Many people claim that 15 years ago we didn't have first hop security as well, and it wasn't a problem. But today we have completely different requirements for the network, and the biggest problem I can see is in decision what devices we should buy for networks that are built as new network. Because if we look on the prices, there is an example for access switches that we want to buy for our infrastructure. The switches that supports all these features for IPv4 are approximately $100 per port. If we want this feature for IPv6, we have to buy switches that are 2 times more expensive. So there is a difficult decision whether to buy the switches that supports these features only for IPv4 and in 2 or 3 years replace them with another switches, or buy more expensive switches to the network infrastructure. And there is big chance that you will have to replace the switches as well. In Cisco portfolio, these features are also supported only the higher level of Cisco devices, so there are definitely not access port. In many cases, the only solution that we have is somehow mitigate this problem by monitoring the network. So we put some probes into the network and at least monitor these devices, monitor these activities within the network, and in many cases, it's the only thing we can do today. So, go to some conclusions. Deploying IPv6 brings some new security threats. It's obvious, it's new protocol, it's new code in the devices, and there are a lot of books in this code. As IPv6 is not used much, these problems are not discovered yet in many cases, and it's a problem. As I always say, it's better to have attended traffic. So if you deploy IPv6 within the network, it's better to have some control over the traffic. But actually, there is no option to not deploy IPv6 within the network because all devices support IPv6 by default, and all users that comes to your network have enabled IPv6 by default. So there is no option to install IPv6 on their devices, etc. It's not possible today. And IPv6 enthusiasts will tell you, oh, just turn IPv6 everywhere and don't care about anything. Yeah, that might be true, but they will not be responsible when some troubles appears in your network. So it's in some critical services, it's just the same as other services. If IPv6 is not used, should not be enabled by default, as you not have enabled by default, let's say, Telnet or Secure Shell or some other services. And you have to consider environment that you are working in. Most of you are from the universities and the research companies when there is more open access, and I think there is no problem to enable IPv6 and have these networks open and know that there is possibilities for these attacks, but it's not attractive target for attackers. So it's usually not a problem within the universities. But in the enterprise, it's a much bigger problem. I'm talking with enterprise guys, and there are big risks, and then that is the reason why they refuse deploy IPv6. However, if somebody gets to a conclusion that should disable IPv6 everywhere, is not true. The role of universities and research groups is deploy IPv6 and try to find this problem and discuss about this problem. And this is the important, because it's the only way how we can move forward with IPv6. Use it, discover the problems, discuss about it, and try to improve either products or standards or anything else. So, for more information, only a little advertise at our university. We established a site that are all articles that we have ever published on the IPv6 topics. There are also some statistics, so you can visit this page if you want to some information or contact or anything else. Thank you for your attention.
Thank you, Thomas. If you start setting up, are there any questions? No questions. That is good, because this all cuts into the break. So